Hmm. So tell me, what is the oxidation number of fluorine in CaOCl2? This is called calcium oxychloride, or it is actually bleaching powder. So what is the oxidation number of chlorine? Anji? Okay, so first option is 0, since it contains Cl2. Second option is -1, since it contains Cl negative. Third option is +1, since it contains ClO negative. And fourth is +1 and -1, since it contains ClO negative and Cl negative. Yes, beta. So one answer comes from someone that is it is 0. अच्छा, और कोई? Do you know the structure of this calcium oxychloride? Anyone? Okay, so see, question is, what is the oxidation number of chlorine in CaOCl2? So first of all, if we calculate its average oxidation number, you know, calcium is +2, oxygen is -2, take it as x, so it is +2 -2 plus 2x equal to 0. So that implies x is 0. So oxidation number of chlorine is 0. But it is not because of it contains Cl2. It is average oxidation number. Average oxidation number of chlorine is 0. Actually, CaOCl2 structure is like this. So in this case, the calcium, you know, it is a metal. So chlorine attached to calcium, that gets -1, and chlorine which is attached to oxygen will get +1. So average oxidation number of chlorine, that is equal to -1 plus 1 divided by 2, that is 0. But it is because it contains +1 and -1. -1 because it has Cl attached to calcium, and +1 because ClO group is there. So option 4 is correct. So keep in mind, in bleaching powder, average oxidation number of chlorine is 0, but it is not because there is presence of Cl2. It is the average oxidation number, but individually one chlorine has +1 oxidation number and other chlorine has -1. Understood? Okay. Next question is the molecular formula of a commercial resin used for exchanging ions in water softening is C8H7 SO3Na. Molecular weight is 206. So what would be the maximum uptake of calcium 2 plus ions by the resin when expressed in mole per gram resin. Two by 309, 1 by 412, 1 by 103, 1 by 206. A reaction I will write. You have C8H7 SO3 Na plus calcium 2 plus. So that will give so tell me. नहीं, did you understand the question? एक मिनट, now is it okay? Hello,
Yes.
so I will read it once again. See, the question is the molecular formula of a commercial resin used for exchanging ions in water softening is given. It is C8H7SO3Na and its molecular weight is 206. So what would be the maximum uptake of calcium 2 plus ions by the resin when it is expressed in mole per gram resin? That is the question, right? So you know, if you see the mole, if 2 moles of resin is there, then we need 1 mole of calcium 2 plus. So 2 mole resin is equivalent to 412 gram. So maximum uptake of calcium 2 plus per gram resin, that is 1 by 412. Yes, it is second option, because mass of resin required for 1 mole of calcium 2 plus, that is 412 gram. So that's why maximum uptake of calcium 2 plus per gram resin, that should be 1 upon 412. Okay. Next. नेक्स्ट आपके लिए क्वेश्चन है, how many liters of Cl2 at STP liberated by oxidation of NaCl with 10 gram KMnO4 in acidic medium. चलो tell me in this case what is the N factor of chlorine and what is the N factor of KMnO4? Very good. So it is now very easy question for you. If you figure out how do we calculate. See, number of equivalents, or we can say gram equivalents, is equal to weight over equivalent weight, or it is equal to volume of gas at STP divided by equivalent volume. So you know equivalent weight is molecular weight over N factor, and equivalent volume, option 1. Yes, it is 1. Equivalent volume is molar volume divided by N factor. So question was how many liters of chlorine at STP will be liberated by oxidation of NaCl with 10 gram of KMnO4 in acidic medium, and N factor you know for chlorine it is 2 because you know 2 Cl negative ion gives Cl2 plus 2 electron. So to get 1 mole of Cl2, 2 electrons should be lost, and at the same time in acidic medium MnO4 negative will give Mn2 plus. This reaction we have done so many times, and there is no need to write whole reaction. You can see the change in oxidation number. So N factor for Cl2 it is 2, and N factor for KMnO4 that is 5. Now the relation is between chlorine and KMnO4. So number of equivalents of Cl2 that is equal to number of equivalents of KMnO4. So number of equivalents of Cl2 is required in terms of volume. So volume of Cl2 at STP divided by its equivalent volume. So tell me what is the equivalent volume of Cl2? What is equivalent volume of Cl2? Beta, molar volume is 22.4 at STP. It is divided by 2, that is 11.2 liter at STP. Equivalent volume of chlorine is 11.2, and in equivalent weight of KMnO4, sorry, number of equivalents of KMnO4, it is in terms of weight. So weight of KMnO4 divided by its equivalent weight. So what is equivalent weight of KMnO4? It is 158 divided by 5. So it is, I hope, 31.6. Beta, because we need volume of chlorine. See, how many liters of chlorine at STP. So and that's why we need volume of Cl2. So we take equivalent volume. Come again. Yes, you can use that formula as well. But say you have weight of KMnO4 and volume of Cl2. So that's why I write it like this. And weight of KMnO4 is 10 divided by 31.6 into 11.2. So it comes out to be 112 divided by 31.6. What is the answer here? Tell me. .54, and that is our answer. Now I come to that part. So this is the way to calculate. Now other formula that is N1 V1 equal to N2 V2, that is same. Okay. So in that case, charger बैग दे दो पूरा बैग यार ये वेट So now let us use another formula, that is N1 V1 equal to N2 V2. So that is again number of equivalents of Cl2 equal to number of equivalents of KMnO4. So in that case, how do we proceed? Tell me. Because this N1 V1 means the number of equivalents, because you know normality. Even 1 second. Okay, you mean to say number of equivalents of Cl2, again number of equivalents of KMnO4, and then you proceed like number of moles of Cl2 multiplied by 2 equal to number of moles of KMnO4 multiplied by 5, right? Then number of moles of Cl2 where it is given.
So we need to find given. So moles of Cl2 into given.
Moles of Cl2 into
Given.
See, these are number of equivalents, right? Number of moles of Cl2 multiplied by 2. So now you want to multiply it by volume, right?
Sir, when moles into n factor into V1 or n2 into 2 moles into n factor into V2 actually.
But you know what is N? That is normality. That is number of equivalents divided by volume, right? So number of equivalents is normality into volume, okay. And then you have taken it as number molarity into n factor into volume, right? Okay, now moles you have converted into molarity into M1 V1 into 2, right? And what about this?
So same way.
M2 V2 into 5. Okay, that's the simple normality is converted into molarity. Okay, then
To find V1 and M1 is 1.
how do you get M1 1?
Because 1/4 of KMnO4 will oxidize 1.
Where is written 1 mole of KMnO4? It is written as 10 gram of KMnO4. We don't have 1 mole of KMnO4. We have 10 gram of KMnO4. And we need to know how many liters of Cl2 at STP will be liberated by the oxidation of NaCl. We don't know the amount of NaCl, but we know that 10 gram of KMnO4 is required to oxidize NaCl. And by oxidizing this NaCl by 10 gram of KMnO4, what is the volume of Cl2 at STP that is produced? So I hope कि जैसे मैंने किया ही अभी, that is the appropriate way to proceed. ना, क्योंकि आप यहाँ पे वॉल्यूम ये निकालना है, बट ये वॉल्यूम तो दिया नहीं है, तो इसको हम ऐसा कर सकते थे, इसको वेट ओवर मॉलिक्यूलर वेट लिखते, क्योंकि अगर वेट दिया है तो मॉलिक्यूलर वेट से डिवाइड करो या इक्विवेलेंट वेट से, है ना. वॉल्यूम दिया है तो उसके वॉल्यूम से डिवाइड करो. इसको भी आप ऐसे कर सकते थे कि वॉल्यूम ऑफ Cl2 at STP divided by 22.4 into 2 और 10/158 into 5. तो वही बन गया ना जो मैं पहले किया था. ओके, नंबर ऑफ इक्विवेलेंट्स को उस टर्म में लिखना है जिस टर्म में आपको गिवन हो चीजें. ओके, नाउ question is a 5 centimeter cube solution of H2O2 liberates 0.508 gram of I2 from an acidified KI solution the volume strength of H2O2 solution at STP is, options are 2.24B, 1.12, 4.48 and 8.96. I hope you know the formula of volume strength. We have already done it. Volume strength of H2O2, that is equal to molarity into 11.2, normality into 5.6. Question is, a 5 centimeter cube solution of H2O2 liberates 0.508 gram of I2 from an acidified Ki solution. The volume strength of H2O2 solution at STP is. So we have a relation between H2O2 and I2. And what is the N factor of both? So H2O2, another is I negative. I negative, N factor of I2 is 2. -1 to 0. And what about H2O2? So iodide ion is oxidized. So obviously H2O2 will be reduced. So that means H2O2 should be converted into H2O2 to H2O or OH negative. Because it should gain electron. So its N factor is again 2. So N factor of H2O2 as well as I2 both is same, that is 2. So number of equivalents of H2O2, that is H2O भी बन सकता है. मैं बोल रहा हूँ कि -1 oxygen changes from -1 to -2, simple. So in OH negative as well as in OH negative and H2O, in both cases it is 2 negative. Sorry, -2.
तो उसको बैलेंस कैसे करेंगे?
उसको बैलेंस कर देते हैं. देखो, you have H2O2 to give H2O. So to balance oxygen, it is like this: 2H2O
Yes.
plus 2H plus 2 electron. So H2 is formed in acidic medium, OH negative is formed in the basic medium. Okay?
Okay.
If medium is acidic, then it will give, okay, it is acidified, Ki. So we will use this equation. But is it acidic or basic? Here it doesn't matter, because we need n factor. So we know that obviously if I negative is oxidized, H2O2 should be reduced. So from -1 it is changing into -2. That's our aim. Here it is in basic medium. If you balance the equation in acidic medium by mistake and medium is basic, its n factor does not change. Keep in mind, that remains same. That has nothing.
Medium we just now got one.
In basic,
Acidic medium.
in acidic medium we get 2 beta. N factor. Yes.
Sir, is the answer 1.13?
1.13 bit. No, it is not 1.1. See, number of equivalents of H2O2 equal to number of equivalents of I2. Now, in case of H2O2, volume is given in ml. So, it is normality of H2O2 into volume of H2O2, and it is equal to number of equivalents of I2. So weight of I2 is given. So weight of I2 divided by equivalent weight of I2. But volume is given in ml. Here it should be in liter. If it is given in ml, so see what is the normality of H2O2? That is volume strength of H2O2 divided by 5.6 into volume of H2O2 is 5 ml. So in liter it should be 5/1000. Weight of I2 is given, that is 0.508 divided by, what is equivalent weight of I2? Actually, it is 127 divided by 2. So it is 127 only. So equivalent weight is 127. So here volume strength of H2O2, that is equal to 0.508 into 1000 multiplied by 5.6 divided by 5 into 127. So what is the answer? 4.48. So this is the volume strength of H2O2. So option 3 is correct. See what we did here. We have volume of H2O2 solution. So we multiplied by normality. We have weight of iodine. So we divide it by equivalent weight. N factor in both cases we know, and then normality we have converted into volume strength, because volume strength of H2O2 is equal to normality into 5.6. So normality equal to volume strength of H2O2 divided by 5.6. That's it. Next is a sample of KMnO4 required 50 ml when titrated against 3 millimole of oxalic acid. Normality of the same solution in a reaction with alkaline H2O2 is so in MnO4, KMnO4 active ion is MnO4 negative, and oxalic acid it is COH dot 2H2. This is the crystalline oxalic acid, but active ion in this case is C2O4 2 negative, because 2H plus ion is removed, so it is C2O4 2 negative. So these are the two ions. And next is alkaline H2O2. A sample of KMnO4 solution required 50 ml when titrated against 3 millimole of oxalic acid. So first of all, just calculate the normality of KMnO4 with oxalic acid. Then normality of the same solution you have to calculate in a reaction with alkaline H2O2. So N factor, what is N factor of KMnO4? 5. And what is N factor of oxalate? हाँ, C2O4 gives 2 CO2. So how many electrons I have to add? Remove 2 electrons, because charge should be balanced on both sides. So 2 negative is balanced by 2 electrons. So n factor is 2 here. So what is normality?
Normality in oxalic acid case is 6 divided by 2.
So again we have KMnO4 and oxalic acid. So here let us take N1 as the normality of KMnO4 into volume of KMnO4, normality. But in case of oxalic acid we have moles. So number of equivalents of oxalic acid. So normality, keep it like this, into 50 divided by 1000. Number of equivalents, it is number of moles of oxalic acid multiplied by 2. So here normality comes out to be, number of moles are not given, number of millimoles are given, and number of millimoles given are 3. So 3 into 10 raised to power minus 3, that is number of millimoles, 3 millimoles of oxalic acid into 2 multiplied by 1000 divided by 50. So it should be 6 by 50. So what is the molarity of KMnO4? Molarity is normality divided by n factor. So it is 6 by 50 divided by 5 into, that means 6 by 10. So it comes out to be 0.6. So this is the molarity of KMnO4 in acidic medium. The normality of KMnO4 in acidic medium, that we have. So from that we have calculated molarity of KMnO4. So molarity remains same. So now we have to calculate normality of the same solution in alkaline medium. .0. तो जब 6 by 50 upon 50 मल्टीप्लाई हो जाएगा, ये मल्टीप्लाई हो जाएगा कि डिवाइड रहेगा? सॉरी,
1/5
का 6 by
and divide and factor करेंगे तो पूरा is equal to and multiply by 1/1 ये divide में ये multiplied by n normality divided by n.
ये नीचे आएगा कि ऊपर ही आएगा? ऐसे होगा? तो ये कितना आया? 0.024. So what is the normality of KMnO4 in basic medium? It is molarity of KMnO4 into n factor of KMnO4 in acidic medium. Sorry, basic medium. What is n factor of KMnO4 in basic medium? KMn, it is in basic medium MnO4 negative will give MnO2 plus 7 to plus 4. So n factor is 3. So it is 0.024 into 3. So it comes out to be 0.072. So it should be option 3. Got it? From the first statement, we have calculated normality of KMnO4 in acidic medium. Then we converted into molarity. And then that molarity, from that molarity, we have calculated normality of KMnO4 in basic medium because it is alkaline H2O2. And O2. Okay. Question is, when arsenic sulfide is boiled with the NaOH, sodium arsenide and sodium thioarsenide are formed. It is X As2S3 Y NaOH to give Na3 ASO3 plus X Na2 Na3 ASS3 plus Y by 2 H2O. So what are the values of X and Y? 16 28 26 14. Okay, let us try. Okay, so option 3. What about others? Huh? Okay. So we have As2S3. In As2S3, okay, let me check. Yes, it is 1. In As2S3, As2S3, arsenic is in +3 oxidation state, sulfur is in -2. And on the other side, it is Na3ASO3. So oxidation state of arsenic is again +3. Huh? There is no change in oxidation number. Is there? Okay, means it is not a redox reaction, that means, right? Simply we balance it. So arsenic are already balanced because arsenic is 1 in both the cases. In case of sulfur, we have 3 sulfur. Sulfurs are already balanced. Sulfur is balanced, arsenic is balanced. So we left with NaOH. So sodium, number of sodium, 3 + 3 6. So we multiplied by 6. So 6 NaOH. So now what about hydrogens? So there are total 6 hydrogens. 6 hydrogens. So that means 3 H2O. So 3 oxygen plus 3, 6 oxygen. 6 oxygen. So it is now it is balanced. So X is 1 and Y is 6. तो बिल्कुल ही आसान था. इतनी देर क्यों लगी बच्चा? इज सिंपली 1 and 6. डाउट नहीं करना है, जस्ट स्पीक आउट. जैसा आता है वो रिपोर्ट करो. गलत हो सकते हो आप, बट अगर चुप रहोगे तो गलत ही हो. ओके. The volume of 0.1 normal dibasic acid sufficient to neutralize 1 gram of base that furnishes 0.04 mole of OH negative aqueous solution. चलो.
Formation 0.04 का क्या मतलब है?
0.04 mole, it will liberate, means volume of 0.1 normal dibasic acid which is sufficient to neutralize 1 gram of a base that furnishes 0.04 mole of OH negative ions in aqueous solution. So we have to calculate the volume of that 0.1 normal. Furnishing is it gives 0.04 mole of OH negative. 1 gram of base that will give 0.04 mole of OH negative ion. Yes बेटा. हाँ बिल्कुल.
चलो OH माइनस का क्या सिग्निफिकेंस है?
एसिड जो है वो किसको ऑक्सीडाइज न्यूट्रलाइज करेगा? OH नेगेटिव आयन को ही ना.
Yes.
Which one? Option? Wait. किसका? यहाँ पे आप गलत हो गए. 30 1 सेकेंड. यस. देखो पहले तो मैं एक बात बता देता हूँ आपको. टेल मी वन equivalent of any acid will furnish how many moles of H plus ions? One mole of, yes, one equivalent of any protonic acid furnishes how many moles of H plus ion? Yes, very good. Furnishes 1 mole of H plus ions. Keep in mind. So same is the case with base. One equivalent of any base furnishes one mole of OH negative ions, right? समझे? So now from this statement, could you calculate the equivalent weight of base? Is it possible? Because equivalent weight is weight of one equivalent. What is equivalent weight? Equivalent weight is weight of one equivalent. So see, 1 gram of base weight of base which furnish 0.04 mole of OH negative ions, that is equal to 1 gram. So weight of base which furnish 1 mole of OH negative is equal to 1 by 0.04, that is 25. So this is equivalent weight of base. It is 25 gram per equivalent. Now you can apply that relation. N1 V1 equal to N2 V2, or simply, here it is dibasic acid on one side and base on the other side. So number of equivalents of dibasic acid is equal to number of equivalents of base. So number of equivalents is normality into volume, and for base weight is given, so weight of base divided by its equivalent weight. Normality is 0.1. Volume you have to calculate. Weight of base is 1 and equivalent weight is 25. So volume comes out to be 1 upon 2.25 into 0.1. So 225 into 0.1. So it is 1 upon 2.5. And that is in liter. So volume is, because volume is given in, so in 2000. So it should be 400 ml. So option 1 is correct. इक्विवेलेंट वेट निकाला पहले हमने, और भी तरीके से कर सकते थे, बट वेट ऑफ वन इक्विवेलेंट होता है इक्विवेलेंट वेट, एंड वन इक्विवेलेंट विल फर्निश 1 मोल ऑफ OH नेगेटिव आयन. मैंने बोला 1 मोल OH नेगेटिव आयन जो फर्निश करेगा, दैट इज इट्स वन इक्विवेलेंट. क्योंकि आप देखो, you have, let us say, H2SO4. What is its molecular weight? What is molecular weight of KMN of H2SO4? 98 gram. So it will give 2 mole of H plus ion. That is its molecular weight, because it is dibasic acid. And what is its equivalent weight? What is the equivalent weight of H2SO4? 98 by 2, that is 49 gram. So 98 gram will furnish 2 mole of H plus ion. So 49 gram will furnish, that's it. Same, let us say we have H3PO4. It will give 3 moles of H plus ions. So what is molecular weight? It is again 98. 3 plus 31 plus 64. So 98 gram, and what is its equivalent weight? (98 by 3). So 98 gram of H3PO4 furnishes 3 moles of H plus ion. So 98 by 3 gram of H3PO4 will furnish 1 mole of H plus. So equivalent weight, that is one equivalent, that always furnish 1 mole of H plus ion, and one equivalent of base always furnish 1 mole of OH negative. HNO3 oxidizes NH4 plus ions to nitrogen, and itself gets reduced to NO2 . The moles of HNO3 required by 1 mole of ammonium sulfate is just calculate N factor of HNO3 to NO2 and NH4 plus to N2. And then equate the number of equivalents. No need to balance, beta. That's why I am giving you practice of so many questions. ताकि अगर आप उसमें लगे रहोगे तो बैलेंस ही करते रहोगे. बैलेंस करने को हमें अवॉइड करना है. Yes. And what about NH4 plus 2 N2? See, HNO3 to NO2, and let me check.
No, sir, N factor is 6 for NH4 plus 2.
See, okay, it is plus 5 to plus 4. So for here HNO3 N factor is 1, and in case of NH4 plus to N2, you know what is the oxidation number of nitrogen here? -3 to 0. So N factor of NH4 plus, that is 3
2 से मल्टीप्लाई होगा ना नाइट्रोजन के लिए.
बेटा nitrogen is not in the picture. We have NH4 plus, but here it is NH4 twice SO4. Then its N factor is 6. Not because of N2, but because in ammonium sulfate there are two. हाँ बेटा बेटा बैलेंस नहीं करना है, क्योंकि इन NH4 plus we have only one N. If it is N factor of N2, then it is 6. N factor of N2 in this case is 6, but N factor of NH4 plus it is 3, because in NH4 plus there is only one nitrogen. But when we have this 1 mole of ammonium sulfate, in ammonium sulfate, 1 mole of ammonium sulfate, we have 2 moles of NH4 plus. That's why N factor comes out to be 6. Okay. So in this way, number of equivalents of HNO3, that is equal to number of equivalents of ammonium sulfate. Now, number of moles of HNO3 that we have to calculate, number of moles of HNO3, it is multiplied by 1, because N factor of HNO3 is 1, and the number of moles of ammonium sulfate, into 6. So number of moles of HNO3, that is equal to number of moles of ammonium sulfate. How many number of moles of ammonium sulfate are given? 1. So 1 into 6. So it should be 6 only. So 1, 2, 3, 4, 5, 6. 6, 3. Yes, it is 6. So option 3 is correct. Got it?
Sir,
Yes, but
sir, request is sir, क्या आप थोड़ा सीक्वेंस बता सकते हैं कि कौन से चैप्टर 11th और 12th मिक्स होके सब चैप्टर बने?
हाँ बेटा, ये जो 2 चैप्टर हमने किए ना अभी तक, एक मोल कंसेप्ट किया फर्स्ट चैप्टर, और ये है 11th का ही 6th चैप्टर. 6
भेज सकते हो अगर आप ट्राई कर
क्या बोल रहे हैं?
आप ग्रुप में भेज सकते हो अगर लिस्ट बना दो.
अच्छा
चैप्टर
अच्छा, कौन से चैप्टर 11th में है, कौन से चैप्टर 12th में है? ये देखो, मैं पहले आपको ना जितने भी चैप्टर करवाऊंगा ना, वो 11th के ही होंगे. ठीक है, जो भी मैं अभी स्टार्ट कर रहा हूँ, जितने भी चैप्टर, वो पहले मैं 11th के ही कवर करूँगा. ठीक है, हाँ जी. अच्छा, बैक जाऊँ क्या? यहाँ तो अगला चैप्टर कौन सा करना है आप लोगों को? थर्मोडायनेमिक्स. ओके, थर्मोडायनेमिक्स चैप्टर भी 11th का ही है बेटा, है? हाँ जी.
सर थर्मोडायनामिक्स या फिर इक्विलिब्रियम?
हाँ, पर बेटर फर्स्ट थर्मोडायनेमिक्स करते हैं, फिर इक्विलिब्रियम पे आ जाएंगे. अब ये जो इक्विवेलेंस वाला कंसेप्ट समझाया ना मैंने पूरा, वो थर्मोडायनेमिक्स में नहीं, पर दूसरे चैप्टर में अगले, मतलब इक्विलिब्रियम में यूज होगा पूरा. ज़्यादा टाइम जो लगाया ना मैंने इक्विवेलेंट्स पे, ये सारा कंसेप्ट यू हैव टू यूज इन इक्विलिब्रियम चैप्टर। सो हम अगला चैप्टर करेंगे थर्मोडायनेमिक्स नेक्स्ट टाइम। इस चैप्टर का आपका इस बार टेस्ट हुआ नहीं हुआ होगा ना? तो नेक्स्ट टाइम इस चैप्टर का टेस्ट होगा आपका, और थर्मोडायनेमिक्स वी विल स्टार्ट इन द नेक्स्ट क्लास।
सर आप इस चैप्टर के प्रैक्टिस करने के लिए होमवर्क में कुछ क्वेश्चंस ले सकते हो?
ठीक है, मैं वो 3-4 आपको असाइनमेंट्स भी भेज देता हूँ। ओके बेटा, बाय, यू कैन लीव। ओके बाय बेटा। ए पाई दे रोटी रिमी, रिमी बोल